Hello good people, I would like to talk a little bit about how we go from this Arrhenius equation up here on the right to this one down here on the left, which we have used in the previous problem. So the first thing we need to do is get rid of this irrational number e. A way to do that is to take the natural log of everything. And then if I rearrange that formula a little bit, I will get to this formula here, where I'm saying that the natural log of K equals negative activation energy over the ideal gas constant multiplied by 1 over the temperature at which the experiment was carried out, plus the natural log of the frequency factor. I can rearrange that a little bit more by moving everything on the left so that I'm left with 0 on the right. Okay, now we get to the crux of the matter. This equation holds true for all of our experiments. That means if I have experiment 1, I can use the rate constant of experiment 1 and the temperature of experiment 1. But I can also do the same thing for experiment 2. I can plug in K2 and T2 into my formula. If you look closely, you will notice that both of these formulas equal 0. That means that I can say that this formula up here equals this formula down here. And we will get this expression at the bottom. Let me just scroll down a little bit to give us some more space. And now we can see something really nice. We can see that we have the frequency factor ln, so natural log of A, on both sides. That means I can cancel it. I can finally get rid of that, and I do not need to worry about it anymore. And then I can rewrite this expression. And I'm just going to use my copy-paste tool to speed things along. So I can say that the data from experiment 1 will equal the mathematical expression for the data from experiment 2. Once again, copy-paste. Awesome. Okay, and now I'm going to tidy up this expression a little bit by making sure that my rate constants are all on the left-hand side and everything else is on the right-hand side. That means shuffling some things along, so I will rewrite this bit, and then minus ln K2 plus, and I will do this step by step, this component here, copy-paste, equals whatever is left on the right-hand side, and that is this component here, copy-paste. Okay, now I'm going to move this component over to the right-hand side. That means that this will remain the same, copy-paste, and it will equal this component, copy-paste, minus, pardon me, this component here, copy-paste. Okay, now I can tidy this up a little bit further. The rules of log tell us that ln K1 minus ln K2 is the same as, pardon me, is the same as ln K1 over ln K2. And when I look on the right-hand side, I can see that there is a common factor in both of these expressions. So there is the activation energy over the ideal gas constant. So I can factor that out. Let's do it correctly. So I will have activation energy over the ideal gas constant multiplied by 1 over T2 minus 1 over T1. And that, if we go back up, is the equation we used, go back up a bit more, we used in the previous question. So I hope that helps you a little bit, if only to show you how we go from this equation up at the top to this equation that we actually used in our problem. That is all for now, and I will see you on the flip side.